Hello, this is Rohan Dillon, and today we'll be taking a look at the last 5 problems from the 2013 AMC 8. First up, problem 21. Samantha lives 2 blocks west and 1 block south of the southwest corner of City Park. Her school is 2 blocks east and 2 blocks north of the northeast corner. On school day, she bikes on streets from her house to the southwest corner, then goes through the park, then goes from the northeast corner to the school. So if her route is as short as possible, how many different routes can she take? We only need to find how many ways there are to get from her house to the southwest corner of the park, and from the northeast corner of the park to her school, since she just takes a diagonal route through the park, and she'll always take a diagonal route through the park. So, for the southwest portion, we have this right here. So we have to go right 2 times, and up 1 time. So we can represent the sequence of moves she takes as right, right, up. Similarly, for this thing here on the northeast corner, we can represent the sequence of moves she takes as right, right, up, up. Now, for right, right, up, the amount of ways you can sort of arrange those 3 letters is 3. You can either go up last, middle, or first. So this would give us choose 2 ways to go from her house to the park. Similarly, to go from the park to her school, we have to find the number of arrangements or permutations of R, R, U, U. This is just 4 choose 2, which is 6 ways. So our total will be 3 times 6, which is 18 ways. Problem 22. Toothpicks are used to make a grid that is 60 toothpicks long and 32 toothpicks wide. How many toothpicks are used altogether? So each row has 60 toothpicks and each column has 32 toothpicks. The problem gives us this. There are 61 columns and 33 rows. That's because if we look at this, we can see that, at least for the columns, the first toothpick has a row above it and a row below it. The second toothpick has a row above it, but we already counted that. So we can only look at the row below it. And you'll see, at least for if you take this subsection, when you have 2 toothpicks on a column, you'll have 3 rows of toothpicks. So the number of rows is always going to be the number of vertical toothpicks plus 1, and the number of columns is going to be the number of horizontal toothpicks plus 1. Therefore, there are 60 toothpicks per row and 33 rows, plus 32 toothpicks per column, plus 61 columns, for a total of 3,932 toothpicks. Problem 23. Angle ABC of ABC is a right triangle. The sides of ABC are the diameters of the semicircles shown. The area of the semicircle on AB equals 8 pi, and the arc of the semicircle on AC has a length of 8.5 pi. What is the radius of the semicircle BC? So the radius of the smallest semicircle on AB, is 4, because its area is 8 pi, so if we imagine it being a full circle, its area would be 16 pi, and since the area is just pi times the radius squared, the radius would have to be 4 for the area to be 16 pi. And AB is the diameter of the semicircle, so it'll just be double. Similarly, the radius of the semicircle on AC is 8.5, so AC is 17. That's because the arc of semicircle AC is 8.5 pi, so if you imagine a full circle, that would have an arc length of 17 pi, and since the arc length is just pi times the diameter, that will give us a radius of 8.5, or a diameter, which is AC, of just 17. So we can use the Pythagorean theorem on this to find that AC squared minus AB squared equals BC squared, or you can just recognize that 8, 15, 17 is a Pythagorean triple. But then, either way, we find that BC equals 15, and so the radius of the semicircle has to be half of that, which is 7.5. Problem 24. Squares ABCD, EFGH, and GHIJ are equal in area. Points C and D are the midpoints of sides IH and HE respectively. What is the ratio of the area of the shaded pentagon AJICB to the sum of the areas of the three squares. So let the intersection of AG and DI be X. So we have that IJ equals AD because they're both squares of side length 1. We also have that angle ADH is congruent to angle JIX because ADH is a right angle since it's one of the angles in a square, and JIX is also a right angle because it's also one of the angles in a square. Furthermore, AHD is congruent to IHJ because they are vertical angles. Thus, we have that ADX is similar to JIX by angle-angle-side congruence. So we can then essentially shade JIX white and shade ADX gray without changing the total area that is gray or white, and now it's a lot easier to see that 1/3 of the figure is shaded, since 1 out of the 3 squares is shaded. Finally, problem 25. A ball with a diameter of 4 inches starts on point A to roll along the track shown. And we have 3 semicircles. R1 has a radius of 100 inches, R2 has a radius of 60 inches, and R3 has a radius of 80 inches. The ball always remains in contact with the track and does not slip. What is the distance the center of the ball travels over the course from A to B? So when the ball rolls on the inside of a track, it loses 2 pi inches, as we can see on this figure in the bottom right. If you look at the arc the center of the ball makes versus the arc that it's going along, we see that the arc the center of the ball makes is a little bit smaller. In fact, it's 2 pi less because if you imagine the semicircle made by this dashed line, well, it has a radius of 2 inches less than point A because the radius of the ball is 2 inches. It's 2 pi inches shorter than the semicircular arc the ball is rolling along. Similarly, when the ball rolls on the outside of a track like R2, it gains 2 pi inches, because for that track, this dashed line is going to be on the outside. So this dashed line will actually be longer than the length of the semicircular arc itself. So the circumference of the semicircles are 100 pi, 60 pi, and 80 pi in that order, because their circumference is just their radius times pi. Thus, the ball travels 100 pi minus 2 pi on the first one, 60 pi plus 2 pi on the second one, and 80 pi minus 2 pi on the third one, for a total of 238 pi inches. Thank you, and I hope you enjoyed this exploration into the last 5 problems of the 2013 AMC 8. Please like and subscribe for more videos.